All right, so let's talk about these problems. Also, I'm sure if you guys just noticed, I forgot to start the recording at the very beginning class, so I just started it. I'm sure it popped up on your screen somewhere. I apologize about that. But the good news is we didn't miss any of the explanations for the problems we're doing, so yay, that'll all be recorded. So, on this first multiple choice question, right, the correct statement that completes the sentence here is the poll used a method that gets an answer within 3% of the truth about the population. Wait, is that the right one? Yeah. Why can't I read this today? The poll used a method that gets an answer within 3% of the truth about the population 95% of the time. Blah, blah, blah. Sorry. So this is because this is asking about our confidence level, right? The confidence level refers to how often over the course of doing the same sampling over and over again, same size sample, how many of our intervals, the resulting intervals from those samples, will contain the true proportion. Right? And in this case, the true proportion within plus or minus 3 percentage points. Right? So the correct answer is the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. Right? The rest of the options have something wrong with them. Right? We don't have the information here to say that the percent of adults who expect an inheritance is between 25 and 31%. So the three options, well, all the other options that have that in there, maybe if we actually calculate confidence interval, and this is saying that the confidence interval, they just did the 28 plus 3 and minus 3 to get these numbers, right? That's only from one sample, right? It's not a 95% chance. We could be 95% confident, right? But it's not the correct interpretation. Is there anything I can clarify about this? Any questions? Okay, so now we'll look at the second multiple choice question about rolling tongues. All right, and for this question, all right, the margin of error is closest to 0.04. Right? And that was the most popular answer for this question, so that's good news. And we're going to look at the math behind this. How did we calculate it? Let's go here. All right. So, based on this context, the sample proportion is 317 out of 400. We get 0.7925 as the value for p hat. We have a sample size of n equals 400. And the critical value z star is 1.96 for a 95% confidence interval. And that's from the result that we saw yesterday in class, that 1.96 is a better estimate, a more accurate estimate for the critical value than using 2, which is what we had been using based on the 68, 95, 99, 7 rule. We then used this formula, the my brain's not cooperating anymore today. Margin of error equals z star times the square root of p hat times 1 minus p hat over n, right? Critical value times standard error equals, now we're replacing our values here, 1.96 times the square root of 0.7925 times 0.2075 divided by 400. We get approximately 0.036. So the closest margin of error that we have to choose is 0.04, because in this case we would round 0.036 up to 0.04. We would not round down to 0.03 because we're closer to 0.04. Okay. Is there anything I can clarify about this problem? About the math that I just showed here? Okay. So now we're going to move to the next two questions. We have two more multiple choice questions here. The third one, right, you want to design a study to estimate the proportion of students at your school who agree with the statement, the student government is an effective organization for expressing the needs of students to the administration. You will use a 95% confidence interval, and you would like the margin of error to be 0.05 or less. You need to calculate the minimum sample size required. Right, so you're going to be using the formula here, right, on page 2 for this question number here, multiple choice 3, slide 5. Okay. Multiple choice number 4, a newspaper reporter asked an SRS of 100 residents in a large city for their opinion on the mayor's job performance. Using the results from the sample, the C% confidence interval for the proportion of all residents in the city who approve the mayor's job performance is 0.565 to 0.695. What is the value of C? In other words, what is the percentage confidence that we have in the interval? And for this one, you'll have to use this one sample Z interval, but you're going to have to do a little bit of like manipulation with stuff to get there, to get to where you need. So we're going to look at question or slide 5, multiple choice number 3 first. So if you're following along, I recommend going to the shared screen that I am sharing so you can see what I do. So for this, the minimum sample size required, right, will be 385. Right? Looks like 11 of you guys selected that, so that's good news. Good job. And here's the math. All right, so to start this question, we have to guess the value for p hat. We're not provided anything to start with. Right, as far as, you know, it's just, we weren't given a sample proportion. We didn't do a small survey to start. We don't have an idea. Right? Because we don't have anything to go off of, we use 0.5. Right? The margin of error that we want is 0.05, less than or equal to 0.05. And we want a 95% confidence interval. So that gives us a z-star critical value of 1.96. We're going to use this rule, this formula here, that z-star times the square root of p hat times 1 minus p hat divided by n is less than or equal to the margin of error. For me, I'm going to rewrite this. I'm going to rearrange this formula before I put my values in to already be set up to solve for n. Now you don't have to do this step. I like to do this because now I just solve one side of it. You want to be a little more familiar with the rules and how to manipulate them first before you do something like that. So we get n is greater than or equal to z star times square root of p hat times 1 minus p hat divided by the margin of error, all of that squared. So we replace our values. We have n is greater than or equal to 1.96 times the square root of 0.5 times 0.5 divided by 0.05 squared, and we get 384.16 approximately. Right? Because this is an inequality, and it says n is greater than or equal to 384.16, I cannot round down to 384, even though I'm closer to 384 than 385. We must round up. So that makes the minimum sample size 385. Right. Is there any questions? Is there anything I can clarify about what just happened? If you're looking at this and you think it looks like Chinese characters, you should ask a question. Get clarification. All right. And moving on to multiple choice 4. What is the value of C? What is our percentage of confidence? In this one, it is 82. Right, now this one took a little bit more legwork. Right? We had to do a lot of kind of piecing of things together to get this. Right, so let's look at the math. Right, we start, and hopefully you're noticing that when I solve problems, I'm doing this the way that I would do it, like on my own. I'm not setting it up the way that like the book says it. This is how I work through problems. I start by listing the things that I know or the things that I'm looking for. I have a C% confidence interval that goes from 0.565 to 0.695. That's given information. My sample size was n equals 100. I do not know Z star. I can find it. It's going to take some work, but I don't know it yet. All right. I can start by finding the sample proportion, p hat, because I have the interval, and this my p hat needs to be right in the middle. So I find the midpoint between these two ends. We get 0.565 plus 0.695 divided by 2. 1.26 over 2, we get 0.63. That is the value of p hat. I can then find my margin of error. Right? And that's because I use this rule up here. This is our basic kind of rule for confidence intervals. It says our confidence interval is the statistic plus or minus the margin of error, which is critical value times standard deviation of the statistic, or the standard error. All right? Because I know how far I need to go from p hat to each endpoint, I just need to determine how far that is. So the margin of error is 0.63 p hat minus 0.565, my smaller endpoint. I could do 0.695 minus 0.63 and I'll get the same value. Right, and we get 0.065. 0.065 represents the margin of error. Right? Which means I can now use this formula, margin of error equals Z star times the square root of p hat times 1 minus p hat over n, replace it with the values I have, which I can now solve for Z star. Right, so we rearrange this equation, and we get Z star equals 0.065 divided by the square root of 0.63 times 0.37 all over 100. And this gives us 1.35. So our Z star is 1.35. But again, I'm working backwards. I'm kind of like the reverse way through all of this work. So I need to take that Z star, convert it to a Z score. So I throw a negative sign on it. And I find that value on table A. All right, so I go to negative 1.35 on table A, trace that to the interior, and we get a proportion that is the proportion less than 1.35 on a standard normal curve is 0.0885. Let's see, I think I still have this here. Yep. All right, and we can see that here. I go to negative 1.35, 0.05, trace that to here, and we get 0.0885. This is having to do with how we get the Z star of 95% confidence that I showed earlier today in another class. Okay, so that's how we get 0.0885. However, the 0.0885 is just the area of the left-hand side tail. Remember, I'm capturing the middle proportion, the middle percentage. So I have two tails, the left-hand side and the right-hand side. I have the area of the left-hand side. the area of the left-hand side is the same as the area on the right-hand side, so I double it. So I go 0.0885 times 2, because I have 2 tails. That's my leftover percentage outside of my confidence percentage, and that equals 0.177. 1 minus 0.177, right? So now I'm solving for what's the percentage in the middle that I'm getting, and I get 0.823. So C is about 82, or an 82% confidence interval. And that's how we get there. There's a lot of kind of using pieces of what we know now and kind of building up to what we need. What can I clarify about that? There was a lot of math going on there. What questions do you have? No questions, okay. All right. So now we're going to open up the next question. It's about 93% confidence. We're going to use this table, and again, I know it's small. I apologize. I don't know how to make it bigger. But you can draw on this table, so this is to kind of help you guys practice using table A. We're going to find the Z star for a 93% confidence interval using table A. We're going to sketch on the copy of table A, showing the proportion to the left of the Z-score that corresponds with a 93% confidence interval. All right. So we're kind of dealing with a similar thing that I was just talking about, where 93% is the percentage in the middle of my distribution, which means I have 7% remaining that gets split evenly between the 2 tails. Right? The proportion of the area of the 2 tails is half of 7%, or 3.5%. We need to convert that to a decimal, right? 0.035. No. Yes, 0.035. And we have to find that decimal on the interior of table A, trace that to the left, to the left-hand Z column in table A, and up to the top row of table A for Z to find the Z score that corresponds with that, and then we convert that Z score, right, drop the negative, to have the Z star value. All right, so from what I can see, a lot of you guys are on the right track. One thing to remember, the critical value Z star is always going to be a positive number. Even though we're finding a negative value on table A, that would be the Z score, the standardized score, right? We always take that standardized score, switch it positive for the Z star value, right, for our critical value. Because our distance, the thing we add and subtract to our statistic, is always going to be a positive value. We're going to add it, we're going to subtract it. All right. So the Z star, the critical value we should have gotten, is 1.81. Okay, from table A. If you got something slightly different, but you're very, very close, this should be okay. Now, here's how we get there. So we start with 93% confidence interval. We subtract 0.93 from 1. We get 0.07. Right? 0.07 is 7% as a decimal. We take that 0.07, divide it by 2, we get 0.035. We then go into table A, we find the closest value to 0.035, which is 0.0351. We then follow that over to the left-hand column, negative 1.8, and up to the top row, 0.01. Combine those two numbers, we get Z equals negative 1.81, which gives us a critical value, Z star, 1.81. Okay. Is there anything I can clarify? Any questions you have? Okay. That's actually where we're going to stop on this activity for today. I do have some more problems in here in this activity. I always plan a little bit more than we can typically kind of get to in these activities because I definitely don't want to run out of stuff. So you can always go back into this activity and look at those problems and practice with those if you want. Stop the pacing here. I'm going to stop sharing my screen. So that's what we have planned for today. We do have the practice problems and their solutions for section 8.2 available in Canvas. And the example problems from yesterday are in the calendar part of my homepage in yesterday's date on the calendar. And you can also access this activity through the calendar or through the modules. Yeah. So if you have any other questions, anything you'd like clarification on, please let me know. Stick around, stay in the class. I'll be happy to answer any and all questions having to do with this or previous sections. And other than that, I will see you all on Tuesday next week. Have a great rest of your week and an awesome weekend.